Hello. This is video 1 for Computer Science CS1. And before we can go even one step further, we have to know what computer science is. So I'll make that the very first question that we discuss in air quotes here. What is computer science? Answer. Well, you learn how to program, you learn programming language, and you write a bunch of programs, and that's computer science. The end. No. The whole design of this class is built around the idea that that is not all there is to computer science, even though that's where most people jump in. I'm going to say it's the study. It is a study, an art and a science, all rolled into one study. The study of how to solve problems with computers. A famous quote was something like, computer science is no more like computers than photography is about cameras. And I kind of like that. I wish I could remember who said it, maybe Galileo or somebody. But the study of how to solve problems with computers. So really what we're doing is solving problems in computers. It's almost like an afterthought. Once you get it all figured out, this is how you do it, then you can pass that off to your minions in the cubicles and they have to figure out how to write the program. Now, that is not even a satisfactory answer for me, so I'm going to split that up. That's answer number 1. Answer number 2 is more of a question again than it is an answer. I'm going to say depends on what level you approach it. What computer science is. And then now I have a flashback of that parable of the blind man and the elephant. And the elephant looked completely different. One blind man got the ears and thought an elephant was a big flat thing. Somebody got the trunk and thought the elephant was like a python. Yada, yada, yada. All those sorts of things. It depends on where you approach it. Some people approach computer science at the high level. Some at the low level. I'm making use of the video screen here. And some get right in the middle. That sounds like a big joke, but it's actually not. All those levels have very different views of computing. If I have left space on the room, what was that? If I have space left on the board, I don't. So I won't even answer that question. I'm going to erase this. Come on, coffee, kick in. Got to get back in school mode here. Feel good, I feel strong, I think I can do this. Here's where most people come in, right here. I'm going to put this right in the middle as much as I can, mid-level. Mid-level is pretty much about programming. Programming in high-level languages. I'll go ahead and break the seal on that term. High-level languages, abbreviated languages, LAN. I use lots of abbreviations. My excuse is it's a small whiteboard. We're just going to have to get used to that. So you might have to back up the video and hear what word goes with that. That's abbreviated for languages. High-level languages. How about Python? That's one we will come to know and love in some detail. Also, Java. You've heard of these. Maybe C++. Maybe or not. You've heard of maybe or not. Swift. SWIFT. I'm going to have to relearn how to talk. I've forgotten how to YouTube here. Python, Java, C++, Swift. Those are all high-level languages. Those are all things you type in and write programs in. And it almost kind of begs the question, well, what other kind of languages are there? Well, funny you should ask. I'll get to that in a little bit. At the programming level, you know what? I'm going to put a metaphor over here. I'm big on metaphors. Since computer science is all new and everything, let's map it back to an old science. If this is the computer column here. I'm going all directions here. This is the computer column. We're halfway down. This will be the physics column. P-H-Y. SICS. And I'm going to say that at the mid-level here, right smack in the middle, are observable phenomenon of the sort of like a bouncing ball. You can do physics experiments with a bouncing ball. That's right at the human level, where you can bounce the ball and see if how far it comes back up. Bounce a ball of a different material and see if it doesn't come up as far. That's about as much physics as I know. So I'm going to have to stop there. But that's my metaphor. We are at the bouncing ball level when we're doing programming, and I beat that to death. Let me move on. What about the low level? The low level could be somewhat mysterious here. The low level is all zeros and ones, true and false. No gray area here. True and false, yes and no, black and white. No middle ground. Everything is zeros and ones. What do I mean by everything? Well, let me see. The data. If you get your favorite DVD, Frozen, and hold that up to a real bright light and look at it under an electron microscope, you're going to see that it's nothing but a plastic sandwich with a real thin sheet of metal in it that has lasers, semi-melted parts that are a little bit dull, and metal parts that are completely shiny. The completely shiny parts are zeros. The little bit melted parts are ones. That's all. Frozen is nothing but a bunch of shiny and melted parts that are all zeros and ones at the lowest level. It's unbelievable. It's miraculous. But that's what's going on at the low level data-wise. What's going on at the low level instruction-wise? A running theme throughout this entire course is you've got kind of like two things, just like in English class. I mean, there's a metaphor there. In English class, you don't only just talk about nouns, rock, house, car. You talk about what they can do. Drive, explode, melt. Those are the verbs. These, the things that are stored in zeros and ones, the data I just talked about, all that data on the Frozen DVD, that is the data. Those are the nouns. The verbs are the instructions, the program instructions, what they can do. And you might think, well, how's that going to be different from the program stuff at this level? What's going to be different is my CD is stuck, and that is very distracting to me. I'm going to see if I can put that out of my mind. We're stuck on the same. We're stuck on the same. Sounds like the same little 0 and 1 over there. I don't know if you can hear it, but I've got background music playing to try to keep the dogs calm. It's part of my setup here. Back to the drawing board, literally. The instructions that operate on zeros and ones, they can only do things like, is that 0 equal to that 1? Are those two things equal to each other? Is this one bigger? It can do that. Add two of those things together. It can do that. That's it. It doesn't do any wild and crazy calculations. It doesn't check to see what the temperature is outside, any of that stuff. At the very lowest level, the instructions in the computer can only do very simple operations and only up to two things at one time. Sometimes it just does an operation on one thing. Is this thing positive or negative? Two things, it can add those up. And you might think, well, yeah, I can think a lot of two operations. That's still going to be a pretty big instruction set. Let's see, it can add, it can subtract. I'll stop you right there. It can subtract. Subtraction, as we're going to find out ourselves when we are operating at this level in this course, subtraction is actually a specialized form of addition because the poor little computer doesn't even know how to subtract. What's going on over here? I've neglected physics for a while. The physics, this is stuff at the atomic level. Atoms. You know what, for visual interest here, bouncing ball. Here's the picture, the bouncing ball. It bounces, doesn't come up quite up as much, and look, that's the bouncing ball right there. And an arrow to show the direction the ball is bouncing. That makes it a lot clearer, doesn't it? Atoms, that just gives me an excuse to draw an atom down here. That's an atom. There. And all those quarks and electrons and things. And rapidly I get out of my element, so to speak. So I'm going to stop talking about those. But these are things that are almost so small and so elemental that it's hard to imagine that big, complicated things can be made out of these atoms. And big, complicated operations in data can be built up from nothing but zeros and ones and yeses and nos and doing real simple instructions like that. But, hey, That's just how it is. We will get a flavor of all of these. What's missing? Well, low, mid, the high level. High level is when you take programs and we even rise maybe 50,000 feet above those, and we start talking in more abstract general terms of gigantic pieces of software called enterprise software. And it's like Star Trek, I guess. Enterprise. Enterprise software. Also living up here at the high level land is object-oriented programming. We're going to look at that a little bit. PROG, apostrophe ing, programming. Why is that high level? Well, past a certain point, even the mighty Bill Gates does not know every line of the Microsoft Word program or the Windows 10 program. Why? Because Windows 10 is what? It's about 40 million lines of code, 40 million lines of mid-level programming. Nobody has their mind around all of that. Nobody knows how all of that works. You've got to stand at the top of the pyramid and kind of conduct from there. You keep up, and you might think, well, you know, that's nothing but manager stuff up here. This is the foreman barking orders to the lower level things. This is actually a very difficult part. Imagine if you had to design your own version of Windows 10 or of Microsoft Word. There are all kinds of considerations up here. And you have to be able to think of these gigantic chunks of code rather than thinking in terms of single lines of code. Now, I apologize if I'm going to do a galaxy up here. Galaxy. G-A-L-A-X-Y. And a galaxy, what I'm apologizing for, yeah, my galaxy is going to look a lot like my atom. Maybe that's profound and I just didn't know it. But what does that swirling... The Milky Way. There. And it has a hole in the middle. It looks like the fried egg I had this morning. It's, that's a galaxy. That's almost too big for our imaginations. This is right at, this is the sweet spot right here. This is right at where most people land in computer science. And we're going to spend most of our time, this module, I almost said semester. Bad, professor. This is where we're going to spend most of our time in this module. We will look at this stuff and try to develop an appreciation for it, and we'll also stick our toe in it a little bit. We'll do some object-oriented programming. Yes, we will. And that's stuff that happens at the Galaxo level, way up there at the top. We'll also we're going to start off here, we're actually going to work our way up, believe it or not. We're going to start at the low level, zeros and ones, and those simple operations that are almost too simple to think about, except those simple operations that are too simple to think about, those are actually responsible for doing every single thing a computer does. All those little things that it can only work with bits and bytes at the very lowest level and only look at two things at a time, bless their hearts. They're doing absolutely everything that a computer's doing. So your frozen DVD that's nothing but zeros and ones, that's being executed by a program that at the lowest level can only look at two tiny little things at one time. It's just amazing. It's still amazing to me, even after all these years in the biz. Now, I've completely filled up the whiteboard and we've covered all the levels. Oh, wait, though. There is a spooky, don't trout. There is a spooky, overlaid, mystical, in a different color. There's not only low, mid, high, there's also theory, the theoretical level, T-H-E-O-R-Y. Let's see, in computer science, now this is supposed to be overlaid on top of this, maybe with a transparent whiteboard. So it's kind of all these levels blended into one. The theoretical side, I know what, instead of putting that in a box to make it stand out even more than just a color, I'm going to put the theory in the cloud. Ooh, there, theory in the cloud. What do we concern ourselves with theory? Things like these sorts of questions. What is even possible to do with a computer? I hope you can see that. Even possible to do with a computer. That's a theoretical question. You might have even heard of a guy named Alan Turing. Apparently he was abused a lot in his lifetime, but his fame since then has kind of caught up with it. And I don't know, I think he was even given an apology by the British government. But let's see, what is even possible to do with a computer? That's how he got all his fame. He wrote this ridiculously complicated, mathematical, challenging paper. And all it was to do was to answer the question, are there some programs that cannot be written? Are there some things that are impossible to calculate? And he proved that, yes, there are. There are some things that no thinking machine, no matter what, can do. Now, a little bit closer to the other stuff that we're concerning ourselves with, the programming and so on, that's still a theoretical question, is stuff like, how good is this program? And good has a very special meaning in computer science. Good means that it runs really fast. It doesn't do a lot of unnecessary work that it doesn't have to do. It doesn't look through a huge long list of things when it can go right to the thing it's looking for. So does it run real fast? That's one way it can be good. Another way it can be good is to not use up more memory space than it has to. Memory space is actually pretty precious real estate in the computer, as we will find out. And as I find out almost daily. That's why I had to switch computers, because my other one kept getting filled up every time I would try to record a video. I guess the program that was running was not theoretically very good. Or maybe it was my computer that's kind of old. But that's how we decide whether or not a computer program is good. And there are all sorts of theoretical ways we can approach that. In physics, I didn't leave space for physics. You know what? Everything fits so well until I tried to overlay theory on top of this. The theory over here in physics, talk about out of my realm of expertise. I'm going to say, what about black holes? That'll be my theoretical physics stuff. I think that's becoming more concrete. They've studied those so much. What about the Big Bang? Where did all this come from? There. That's a theoretical physics question. Maybe the computer science theory is a little more practical than the theoretical physics, but they're both big areas of study. And this, ladies and gentlemen, this is to explode the notion that this was the whole thing, that the programming was all there was to computer science. All of this stuff is stuff that we are going to look at to some degree, some more than others. This is where we'll spend most of our time, because this is what gets us ready for CS2. But the other things are not necessarily going to be things that you will use in your toolbox every day, but I can't say that they won't be. You've got to know all this stuff if you want to be able to do any kind of electrical engineering, circuit design, and all that stuff. You got to be able to do all of this stuff if you want to be a senior level software engineer at Amazon or Microsoft, and I know some of those people. And they work at this level. They don't soil their hands with actual code anymore. They make decisions and then pass it out to the scads of minions in cubicles. So there's all kinds of things. There are even theoretical computer scientists that are pushing the edge of what is possible to do with computers. You've got to study things theoretically and work out all the formulas and mathematics there first before you can even start to write programs for it. So computer science, in other words, is all over the map, also known as, in this context, all over the whiteboard. And that's our intro to computer science and our explosion of the myth that computer science is only programming. And I've said that enough times now that I can't stand to hear myself say it again, and I'm going to close this little video out and say, I'll see you online.